Hello, my name is Luis Serrano and this is Serrano Academy, and this video is about reinforcement learning with human feedback, or RLHF. Reinforcement learning with human feedback is a very useful method used to train large language models. More specifically, to fine-tune large language models after they've been trained. So here's how it works. First, you get a bunch of human annotators, and these human annotators are going to rate the responses given by a large language model to a particular prompt. And then we teach the large language model to win at this game, where winning means getting high scores with the human annotator. And to train the LLM to win at this game, you use reinforcement learning. Let me show you how. So first, let's do a quick review of reinforcement learning. The scenario we've been using is a grid world, which has an agent here that's going to move around, and there are some places with money. And here there's a dragon that will eat the agent if it lands there. If you land on the money over here, you get 5 points. Over here, you get 4 points. And if you're eaten by the dragon, you lose 1 point. And there are also some barriers over here. So the idea is to get the agent to move around and do as best as possible. So for example, here it scored 4 points. And in order to teach the agent, we have some reinforcement learning terms. The first one is the states. So a state is any place where the agent could potentially be at. And then we have the actions, which are exactly the possible things that an agent can do. Here, they're shown as arrows in the floor. Wherever there's an arrow means the agent can walk in that direction. Notice that we made it so that the agent doesn't hit the walls. You could also have the agent hit the wall, but that's not a big deal. Now, in the example we have, it costs 1 point to move 1 spot. So let's say that we're over here in this box and we move to the 5. That is the optimal choice to do there, which means that if we're in this spot, we guarantee that we have 4 points because it costs us 1 to move to the 5. And in the PPO video, we learned how to calculate these values that are here. So wherever you are, the value of the box is the amount of points you get if you play optimally. Then we also have the policy. In this case, the arrows here indicate that if you move in that particular direction, you are moving in an optimal way, because basically we move from any place to the place with the highest value among the neighbors. I invite you to check it out, that anywhere you are, if you move anywhere in the arrows, and sometimes you have more than one option, but that's okay, you can pick anyone, you would do very well in this game. So those are the basics of reinforcement learning. So let me give you a quick review of PPO, or proximal policy optimization. So we have the values and we have the policy, and that means we've solved the problem, right? Well, not exactly, because in order to calculate this properly, the agent has to visit every square in the grid or every state multiple times, and that can be very expensive, especially if we have a really large grid, or if we have a problem with many states or infinitely many states, and that is very expensive, so we need to approximate the values and the policy. This is where neural networks come in. So in order to approximate the values, we use something called a value neural network, and that gives us pretty good approximations for the values. And for this policy, we also use a neural network called a policy neural network, which will give us a pretty good approximation of the policy. Notice that the policy on the right is stochastic, means for each state I have 4 probabilities, one to go up, to the left, down, and to the right. And the larger the arrow, the larger the probability that we're gonna move there. But at every state, we're gonna flip a coin with these probabilities and move in the state that comes out. So in summary, we have the value neural network, which approximates the values, and the policy neural network, which approximates the policy. And the idea of PPO is that we can train these two at the same time. If you need a refresher on how to do this, then check out the video on PPO that I have in the comments. Now, before we get to RLHF, let me give you a quick refresher on transformers. If you want a more thorough refresher, I have a video called Transformer Models. As a matter of fact, it's a series of videos about attention and transformer models, but check this one out. So a transformer is something that generates text. Now, this is something that surprised me when I first found out. It actually generates text 1 word at a time. And as you probably have played with these transformers, it generates some really amazing text. So how does it do it? Well, let's say you give it a prompt, hello, how are you? Then it figures out the best word that follows that prompt. So let's say it's the word doing. So how do we get them to say long pieces of text? Well, one word at a time. Let's say the prompt is write a story. So it figures out the next word should be probably once. And then it puts that word in the prompt or in the input. And then it says write a story once, and the next word that outputs is upon. And then it does that again. It inputs write a story once upon, the next word is and so on and so forth. Now, how do we train transformer models? Well, long story short, we take a huge data set, for example, the entire internet, and feed it to this humongous neural network. A transformer is a humongous neural network with some extra stuff on the side, but basically after being fed all this information, it knows how to talk. Now, it still doesn't know how to do things like answer specific questions or follow orders or carry on a conversation. So for that, you fine tune it. That means you train it even more with a bunch of pretty specific curated data sets. This is a lot of work. But once you train it with these, then you get the transformers that we have played with that are amazing. However, that's not the end of the story, because they still have their problems. They still need to be fine-tuned by humans, because for example, let's say you ask them a question, and you may have experienced this, that they hallucinate, they answer questions wrong. And for that, we need a human to tell it that that's not the answer, that something else is the answer. More specifically, what humans do is that you give it a prompt and then let the transformer output several answers. And then the human annotator will pick the best answer, or actually we rate them from best to worst. And now we're going to use that information from the human annotators to train the transformers. And how do we do it? With reinforcement learning. Let me show you how. Now we're ready to combine these two things. For now, let's pretend that we're still on a grid. Obviously, this problem is not on a grid, but for a moment, let's pretend that it is. So we're going to start building sentences on this grid. So let's say we're going to start here, and every box adds one word to our sentence. So for example, to make the sentence, what color is the sky? Notice that moving to each neighboring state, we added one new word to the sentence. And the idea is that the agent is going to move in this grid forming sentences and playing in an optimal way, which means forming coherent sentences. So the agent is here at what color is the sky, and we have to figure out what the next word is. So it could be blue, it could be red, or it could be banana. Those are, let's say, the three options. And the agent could move to each one of these. Now we need to figure out what's the best one. So for that, we put them over here and we give them to a human annotator. The human annotator looks at the three sentences and says, well, I think the best one is the one that continues the sentence with the word blue. That one gets the gold medal, and the silver medal is for this one. What color is the sky? Red, because it's very unlikely, but you know, there's the occasional sunset where the sky is red. And the bronze medal, or the last one here, is banana, because what color is the sky? Banana is not a very good answer. Now we're going to turn these into points. And we can do this in many ways, and different methods do it in different ways. But for this video, I'm just going to say that the top one gets 3 points, the next one gets 2 points, and the last one gets 1 point. And we assign the points to each one of the states, just like in the Grid World game. And now what do? We train a value neural network to learn these values in the game. Now, what happens with the policy? Well, same thing. We associate the first, second, and third spot here, and we train the policy neural network to give a very high probability to the gold, a smaller probability to the silver, and a really small probability for the bronze. So, we're training the policy neural network to learn this policy. Now, we can do this for longer sentences, right? Let's say we start with roses are red. And let's say that the large language model takes 3 possible paths. The first one is finishing it like this: roses are red, violets are blue. And notice that I've put an end token there. This is pretty common. That means the end of the sentence. Another path it can take is this one: roses are red, violets are human too. Why not? And the last one is this one over here that says roses are red because they like ketchup. So we give this to an annotator, And the annotator says, well, I think the top one is this one. I'm going to give 3 points to roses are red, violets are blue. Then 2 points to roses are red, violets are human too, because at least it rhymes. And only 1 point to roses are red because they like ketchup. So we assign those points and we train the policy neural network to give these actions a higher probability, these actions a slightly lower probability, and these actions over here a very low probability. So in summary, if you're at a state over here, let's say you let the large language model walk around here and it gives you 3 paths. This one over here, this one here, and this one here, and each one of them is a response. So we have response 1, response 2, and response 3. Now we give the 3 responses to an annotator and we let the annotator rate them. So let's say it gives the best response 3 points, then the next one 2, then the next one 1. And as I said, the points can be different, but here we're doing just 3, 2, and 1. But the idea is to give more points to the best response. And then we bring them back to the grid and we have the value neural network learn them. That means we feed these over here in order to train the value neural network. And for the policy network, well, the same thing happens. We want the agent to move around to get the maximum number of points. So we tell the policy neural network to make these probabilities pretty high, these ones so-so, and these ones pretty low. That means we feed all this information into the policy neural network. Again, if you want details about how to train them, check out the PPO video. Now, I made a huge assumption here, which is that we have a grid with sentences, and moving around the grid means adding words to the sentences. Obviously, the space of text is not a grid. It's actually a huge, very high dimensional space where a lot of things appear. Each one of these boxes over here, it's a piece of text, and there are arrows between them corresponding to when we add a word at the end of each piece of text. So for example, over here, there's an arrow between hello, how are you, and hello, how are you good, meaning that if the prompt is hello, how are you, it's very likely that the next word is going to be good. So some of these arrows are thick for high probability and others are thin for low probability. Now let's look at 2 chains that follow the sentence, what color is the sky? One of them is over here, which ends up with what color is the sky? The sky is blue. Since this is a sensible sentence, then it has thick arrows. Now, there's also this one over here, which says, what color is the sky? Banana, purple monkey, dishwasher. That's not a very sensible sentence, so we have very thin arrows for very low probabilities of walking in this path. And now, let's look at these 2 scenarios. What does the value neural network do? Well, since we have the human annotator giving these 3 points and 1 point based on the rankings it gives them, well, the goal of the value neural network is to learn the points that the human annotator will give to each one of the responses. And what does the policy neural network do? Well, the policy neural network learns these probabilities. In other words, the policy neural network learns to give high probabilities when the next word is very likely to be the one there, and low probabilities when it's not. Let's analyze these neural networks just a little more to see what they actually do. So what does the value neural network do? Well, remember that you have a human evaluator that gives ratings that turn into scores. Well, the value neural network simply learns to mimic this human evaluator because the human evaluator basically scores responses based on how good they are, and the value neural network assigns values to states based on how good they are. These 2 are the exact same thing. Therefore, the value neural network is trying to learn and to mimic the work of the human evaluator. Basically, it's trying to predict what score is a human evaluator going to give a particular response. And what about the policy neural network? Well, the policy neural network is learning these probabilities. The probabilities of going between a sentence and the sentence with an extra word. Does that sound familiar? Well, that's exactly what the transformer does. So the policy neural network is the transformer, because the transformer generates text 1 word at a time. Given a piece of text, it finds the next word that has the highest probability of belonging there. That's exactly what the policy neural network does. It finds the best next word in a sentence. So this value and policy neural networks are a disguise for the human evaluator, or at least a neural network that mimics the human evaluator, and the actual transformer that we're training. That's all, folks. That concludes the third video in our series of 4 videos in reinforcement learning. This is reinforcement learning with human feedback. The next one is going to be direct policy optimization, or DPO. So I hope you enjoyed the video. If you did, please make sure you subscribe to the channel for more of this content, and hit like or share among your friends, or put in a comment. Especially if you have any suggestions for future videos, I love to read your comments. You can also check out my page, serrano.academy, where I have a bunch of material, including these videos, plus blog posts, plus a bunch of other things. If you'd like to tweet at me, it's serrano.academy. And finally, if you want to engage more, I have a book called Grokking Machine Learning. Here's a discount code. And underneath in the comments, there's a link for where to buy the book. And the discount code is for 40%. So thank you very much, and see you in the next video.